All right, guys, welcome to part 3 of this lesson. We are continuing 5.1.3. We did 5.1.2 part B first and 5.1.3 part A. So let's call this 5.1.3 part B. Number 42, two problems we're doing, 42 and 43. Adriana had to find the inverse function of f of x equals x minus 3 squared plus 2. She got the equation square root of x minus 2 plus 3. Will her stacked function machine method work? Use Adriana's idea from problem 41 that we just did in the last video to verify that the functions are inverses of each other. Each person on your team should choose a different number for the input. Be sure to stack the function machines in both orders. So f of x and then f inverse and then vice versa. So let's pick a number to plug into our function. Let's pick, what did I pick? I picked 3. Okay, so I'm going to pick 3 to plug into f of x. And let's write our f of x function right here. F of x equals x minus 3 squared. This is a parabola shifted to the right 3 units, up 2 units. So if I plug in 3 into this, we get 3 minus 3 squared plus 2, which was 0 plus 2, which is just 2. Okay, so when I plug in f of 3, I get 2. All right, now if we plug in 2 into the function, into the inverse function was, I'll write it down right here, square root of x minus 2. And the plus 3 is outside. So we're going to plug into the inverse function. We're going to plug our output here, 2. And we should get an input of 3. So we get 3 minus 2 plus 3. 3 minus 2 is 1. So the square root of 1 plus 3 is 1 plus 3. Oh, sorry. Yeah, I messed up. I was like, that is not what I got last time. So this is not 3, this is 2. So I need to erase that and put a 2 there because I plugged in 2, not 3. So 2 minus 2 is 0. So the square root is 0 plus 3. So I get 0 plus 3, which is just 3. So the answer is 3. Okay, so that was good because we plugged in 3, we got 2. Then we plugged in 2 into the inverse function, we got 3. Okay, that's the way it's supposed to work. Okay, let's look at part B. Adriana's friend, Symmetry, decided to check f inverse of f of negative 5. What happened? Why did this happen? Okay, so let's see what her friend is doing. Let's plug in f inverse of f of negative 5. Okay, so this is our f of x function. Okay, a lot of people are confused by this notation, so I hope you guys are really paying attention. Like, what does this mean? It means this is the f of x, and we're plugging negative 5 into the f of x. So we're plugging negative 5 into here, right? So f of negative 5 is negative 5 minus 3 squared plus 2. Okay, that's the inside. That's just this part. We're not doing this part yet. So when we get this, negative 5 minus 3 is negative 8 squared plus 2. If 8 squared is positive 64 plus 2, which is 66. Okay, so now we have to do f inverse of 66 because the value of f of negative 5 is 66. So now we're going to plug that into the inverse function, okay? This is very tricky, so I hope you're paying attention. So when I plug in 66 into here, I'm going to get 66 minus 2, square root that, plus 3. Well, 66 minus 2 is 64, which is a perfect square. That's nice. Square root of 64 is 8. That's perfect. That's nice. 8 plus 3 is, 11. We didn't have an 11. We didn't plug in 11. We're supposed to get negative 5, right? We started with negative 5. We plugged it into the f of x function. We got 66. We plugged in 66 to the inverse function, so we should get negative 5 back. Whoa, what just happened? How come we didn't get negative 5? Okay, let's look at part C. to figure out what happened. How can you restrict the domain? Remember we talked about restricting the domain like I think 2 videos ago, earlier today. This is the 3rd video, I'm losing track. How can you restrict the domain of f of x to make sure the functions are inverses of each other? So these functions are not inverses of each other unless we restrict the domain. These two functions are not inverses of each other unless we restrict their domain. Because remember, this is a parabola, right? And its inverse is going to go like this, and that is not a function. So that's why they are not inverses of each other unless we restrict the domain. Well, what should we restrict the domain to? Remember this? If you have f of x equals x minus 3 squared plus 2, we want this to be, let's do a little graph. We're going to go to the right 3 and up 2. So 1, 2, 3, and up 2. So this graph, and then we're going to go up 1 over 1, up 1 over 1, up 3 over, up 1 over 3, right? We did that earlier in the first part of the video. Okay, so I only want this half of the graph from 3 over, right? So we want to restrict it to x is greater than or equal to 3. Okay, and remember in the last video I said, oh, you could do the part that's inside the parentheses, take that and essentially set it equal to 0, put it greater than or equal to 0, and then solve it. And then you get x is greater than or equal to 3. So we need to restrict the domain. So we have to put this with the restriction that x can only be greater than or equal to 3. Then our y will only be greater than or equal to 3 for the inverse, right? For the inverse function that affects our y. Y values can only be greater than or equal to 3. So we're going to get like this half of the graph. So we're going to take this half of the graph and get that half of the graph. And we're not going to use this half, and we're not going to use this half. Okay, so x is greater than 3 is this half. Okay, so what happened was we picked, the value that we picked, was it greater than 3 when we plugged it in? No, it was less than 3. So it didn't come out like we wanted it to. But the first value that we picked was equal to 3, and that's okay. You can have greater than or equal to, and it worked. You know, that worked out fine. But when you pick a number that's not part of this restriction, it's part of the left side over here, the -5 is way over here, it's not going to work. So you have to remember to restrict the domain. You must restrict the domain to have an inverse function. You have to do this and remember this on the next test. Sketch a graph of the function and its inverse to confirm your answer. So the graph would be this part that we sketched right here, right? And then the inverse, I would erase this part. Let me erase that part. There we go. And then the inverse, I did this earlier on the other video. Remember so this point is 3, 0, no, 3, 2. So we want to go 2, 3 is the inverse of it. And then this point would be 4, 3. So I want to go 3, 4. And then I can start to see, it's going to go like that. Okay, I could do it to this point too and reverse it. So the inverse is going to be like that. Okay, and then I could draw the, what's it called? The line of symmetry, which is y equals x. You always want to draw the line of symmetry when you do an inverse. It's going to go through something like that. So I could do a much more accurate graph, but that's pretty good. All right, so that is problem 42. Super important things to get there. Need to clear this out. Let's do the last problem, 43. Adriana and Statler are writing inverses of some other functions. They come up with these inverse pairs. F of x equals this, g of x equals this. I think I'm missing some directions here. Yeah, let me pause this and look at the directions. Pause, pause, pause. Okay, so this is the other directions that we're missing. Name 3 different methods Adriana and Statler can use to verify that these pairs of functions are actually inverses. Help them verify whether these pairs of functions are really inverses of each other. If they are not, explain what went wrong and write the inverse functions correctly. State the domain and range that is necessary to make each pair of functions inverses of each other. Okay, so for part A, let's see if I can right here, we need to, you know, they can plug in, we can plug in a number, so this is 43, plug in a number into f of x, right? And get some number back, some y value, and whatever you get, plug that into f, then plug that into f inverse of x, right? So we're doing essentially f inverse of f of x, and we should get whatever we started with back. It should equal x. Okay, so we should get x back. So if I plug in like a 3 into here, f of 3, and let's say I get 5, and then I plug in 5 into the inverse function, I should get 3 back. Okay, unless the domains need to be restricted, which is going to happen with some of these problems. Okay, and the other thing we can do is we can plug one function into another. Instead of plugging a specific number, we can plug in one whole function into another. I could like take this whole function and plug it into this function and work it all out, and then I should get x when I'm done. You can't just put, oh, it equals x. You have to test it because some of these are not inverses of one another. So let's try some of those. Okay, and then we could do the reverse of that too. Okay, so I gotta move this bar out of the way. So to test if this is inverse of one another, let's plug in 5 for I. So I'm gonna just plug in a number. F of 5 is equal to 3/5. I picked 5 because it's a fifth, so 5 would be easy to multiply by this. Okay, and so these 5s would cancel out, and I just get 3 minus 15, which would be -8. All right, f of x, 3 times 5, 3 minus 15 should be -8. Okay. Now we're going to plug this into f inverse of this, which is g of x. This is supposed to be the inverse, so of -8. Let's plug it in there. We're going to get 5/3. Wait, why did I get 3 minus? Oh, sorry, I was going to say I got something wrong. So it's not -8. This is -12. I was doing a different 13 minus 5. I was reversing the numbers in my brain. So this is -12. Sorry, -12. So I need to put -12 in here. This is -12, not -8. So when I multiply by -12, that'll make it nicer. 8 was going to be really ugly. Plus 25, because I'm plugging it into this function right here, into the inverse function. So it says plus 25. When I do this, the 3 is going to go to the -12, -4 times, right? And so 5 times -4 is -20 plus 25, which gives me 5. Yay, that is what we're supposed to get because we started with 5, we got -12, we plugged in -12 into the inverse function, and we got 5 again. So this shows us that yes, they are inverses of each other, we think. Okay, so now let's do that for number 2 now. Okay, number 2, j of x is equal to 2 over x plus 10. Well, let's pick 2. Since it's 2 divided by 2, I'm going to pick 2. You can pick any number you want. I'm going to pick 2. 2 divided by 2. Oops, I'm going to put a 2 in there. J of 2 is 2 divided by 2 plus 10, which is 1 plus 10, which is 11. So we get j of 2 is 11. So I'm going to plug in 11 into here, and I should get 2 back, right? Should reverse. That's what inverses do. So k of 11, which is the inverse of j, is going to be 2 divided by 11 minus 10. So you do the 11 minus 10 part first, which is 1. So we get 2, and that's what we started with. We plugged in 2, we got 11. We plugged in 11, we got 2. So yeah, these are inverses. Yes, this is the inverse. Yes, this is the inverse. They are inverses each other for 1 and 2. Now let's do 3. 1, 2, 3 i's. Here, for this one, I am gonna plug in, I'm gonna pick 11. Seems like a good number to plug in because it's 11 minus 10 will give me 1. That's an easy number. So E of 11, how do you know what numbers to pick? Pick ones that are gonna give you easy values. Look at the function. You have to look at the function and make a decision there. Okay, it's not, oh, can I plug in 10 every time? Not necessarily, not unless you want ugly numbers. You have to look at the function and decide. Okay, so 11 minus 10 is 1 squared over 4, which would give me 1/4. Okay, oh, we got a fraction. You can get fractions. So when I plug in 11, I get 1/4. Now when I plug in, this is the inverse function here, d of x. So I'm going to plug in d of 1/4. Yes, you can plug in fractions into any function. I'm going to get 4 times the square root of 1/4 plus 10. The square root of 1/4 is actually a perfect square because 1/2 times 1/2 equals 1/4. So square root of 1/4 is 1/2 times 4. So half of 4 is 2 plus 10 equals 12. Did we drop 12 in there? No, we didn't. So, okay, just want to make sure this is correct. Yeah. So we didn't drop 12, we dropped 11 in there and we got 12 back. So these are not inverses of each other. For number 3, not inverses. Okay, and we'll figure out what we did wrong there in a second. Let me erase, I have to erase to make some room. So I'm going to do 4 over here. 4, 4, 4. Okay, 4 should be IV. And for number 4, let's see, what number should we pick? I could do 3 minus 1. I could do 2 minus 1. I think I did 2. I did 3. I picked x to be 3 for this one because I saw it was going to cube, and I could pick 2 to make it easier, but I just wanted to make it a little difficult. So m of 3 is equal to 2 times 3 minus 1 cubed plus 7. Okay, so I'm plugging 3 into the original function. So I do 3 minus 2, well, that's 2 cubed, not squared, times 2 plus 7. Well, 2 cubed is 8. 8 times 2 is 16. 16 plus 7 is 23. Okay, so we got 23 when we plugged in 3 in. So now let's plug in 23 into the inverse function p of x and see if we get 3 back. Okay, so I kind of need more room again, so I'm going to erase this part. Number 2, I don't need number 2. Number 3, number 1 and 2 both worked, so we don't need those anymore. All right, so let's plug in for p of x, p of 23. P of 23 is going to be the cube root of 23 minus 1 over 2 plus 7 on the outside, plus 7 at the end. So 23 minus 22 is 22. 23 minus 1 is 22 over 2. Cube root of that. So 22 over 2 is the cube root of 11. That is going to be an ugly decimal. Plus 7, because 11 is not a perfect cube. So we get some decimal. Let's say cube root of 8 is 2. So 9 point something, 9 point question mark, question mark, question mark, right? You get some ugly decimal. We did not get what we had 3. So something is wrong with these, okay? So what we have to figure out is what is wrong with that. And we need to basically restrict the domains is what's wrong with it. So I'm going to erase this part and I need to restrict the domain and figure out what we need to restrict the domain to. So let's see. this function is a cubic. Ooh. Okay. And the cubic, I'm doing number 4 first. I should do number 3, but that's okay. I'll do number 4 since it's right here. Remember, the cubic, I could put it in Desmos and see what it does, but it's going to go something like this. It's not a function. It's not going to pass the horizontal line test, so we have to restrict it somewhere. This one is shifted over 1 and up 7. So if I were to graph this, let's see, over 1, 2, 4, 6, 8, 7. So right here would be the middle of the graph. So, and I don't know how far up and down it's going to go. I could plug in 0. 0 would be a great number to plug in and see what you get. But the middle is going to be right here at 1, 7. At 1, 7. How did I put for this last time? So let's check this. Okay, guys, I accidentally paused the recording and I accidentally erased everything. But what I did find was that these are nowhere near inverses of each other. So if you actually go and do the inverse of this, the inverse of x is actually going to be something kind of crazy. It's going to be the cube root of x minus 7 over 2 plus 1 on the outside. And for p of x, the inverse of that one is going to be, since it's a cube root, the inverse is going to be a cube. It's 2 times x minus 7 cubed plus 1. So that's not even close to this. So if these are supposed to be inverses of each other, this function is not that function. They are not inverses of each other. They got the 1 and the 7 backwards. Okay, so, and this is not even close to being this. The 7 should be out here, and the 7 should be underneath here. So these are inverses. So these are the correct inverses. And the domain and range for all of these are all real numbers, which makes things easy. All reals, all reals. Oh, good. For number 3, let me look at number 3. What do we say for number 3? For number 3, we want, since it's an x minus 10 squared over 4, we want to restrict the domain, right? This is just some parabola that is over at 10, 0. It's at 10, 0. So we want to make x be greater than or equal to 10. We need to restrict the domain because that's what would make this go to 0 is 10, right? So since it's been shifted over 10 units, we want to restrict it to x is greater than or equal to 10, and that will work for us. That means for our range on the other one, no, the range for this one, the range is going to be y is greater than or equal to, oh, no, y is greater than 0 for that range, the domain. So for the inverse one, the d of x, d of, well, I won't put d of x, e inverse of x, your x should be, your y should be greater than or equal to 10, okay? And the x should be greater than or equal to 0. So they are reversed, and yeah, these were not inverses of each other. Well, we need to restrict the domain and say x has to be greater than or equal to 10 on that one, and then solve it and see if you get that is the appropriate thing. Okay, I'm going to cut this off now. I got some things to do, and you probably do too. So hope that helps, guys. That is the lesson, super long one, 3 parts, and you have till Friday and or the weekend. This is due Friday, but if you don't, hopefully you get it done by Friday. If not, you could watch it over the weekend too. So yeah.